All right, let's start by going over last night's homework, which was pages 21 through 23. This first question does mention the diagram. So it's mentioning the stages of formation in a meandering river. Which one represents the usual changes over time? And I know you guys thought it was hilarious that I compared stream aging to human aging. But if you recall when I did that, one thing I mentioned is just like humans, rivers get wrinklier, or more wrinkly, meaning they get curvier and bendier. So it actually is right in order. So the answer is number one. They go from being nice and straight to a little curvy to really curvy. So no wrinkles to very wrinkly. Then it asks which location is erosion the greatest? And so there should be more erosion. Actually, I'm gonna let you guys tell me, show me on your fingers, which one letters X, Y, or Z, 1, 2, 3, or 4. Perfect, I don't really need to go over it. So location X, so number 2 has the most erosion. Who wants to say why it has the most erosion? It's the outside of a curve, perfect. Now, one thing I've been saying over and over this chapter is often you do not need to know, like when I say moraine, hey, by the way, what agent of erosion makes a moraine? What? Glaciers. That's what you need to be able to do. I need to say a feature and you need to tell me what agent of erosion makes it. For this exact reason, like here, it's telling you a natural levee. Never mentioned what a levee was. Never even, I don't think, brought it up yet. But they tell you right here what it is. A natural levees are ridges of sediments that slope away from the riverbank towards the floodplain. Which process most likely formed these? So you come up here and you do see that they're labeled. They're these little, they almost look like little hills or ridges that are sloped away from the river towards the flood banks. So you don't expect you to know what a levee is. You just needed to know it was formed by a river. And the sediments, they're asking, well, how'd they get there? So they're ridges of sediments. The answers say by weathering, erosion, or deposition. Which one's going to drop off those sediments? Weathering, erosion, or deposition? Deposition drops off sediments, guys. And then the answers are by the Yazoo streams or when the river overflows. Which one do you think is going to drop off the sediments right here next to the river? 3 or 4? Yeah, that's 4. So deposition when the river overflowed. Why? What did you put? So weathering of the soils of the riverbanks are going to, so if you notice, they're going this way from the river. The weathering doesn't move sediments at all. Weathering breaks. This is why we got to get those words separated in our brain, which I have brought up since the first day we started this chapter. Weathering is the breaking of sediments. Nothing about breaking makes a pile. It's just breaking sediments. Taking one rock and breaking it into 100 rocks. That's weathering. Erosion moves those sediments, but it doesn't say anything about putting them down. Erosion's just the moving. Deposition is when they get put down. So be put in these piles or ridges, that's deposition. How about number 4 then? Let me ask you guys what you put first. If you didn't actually try it, please go ahead and read number 4 before you give me a show of your fingers. During transportation in this river, a sediment particle will most likely become more rounded, more dense, heavier, or larger. Tell me what you said. Don't look at your neighbors, just put up your finger. 1, 2, 3, or 4. Okay, didn't fail that one. Sediments that are transported in a river become smaller, smoother, and rounder. Hey, why? Why do they do that, by the way?
Because it's kind of like tumbling and rolling.
That's the best way to put it, because rivers, when rocks get carried in a river, they don't just float by, they roll. They tumble. And it doesn't mean they're constantly moving either. It could be, okay, one day it flipped it this way. The next day it made another flip. So every time this rock flips, it's going to break off a corner and it's going to become rounder and smoother and smaller. All right, how about this one? Which change would most likely increase the velocity of the river? So speed it up. Is it a decrease in the slope? What does that mean to decrease the slope? When I decrease the slope, what am I going to do with my arm to decrease it? Move down, make it more flat. Will being more flat make it go faster? No. What if I increase the temperature of the river? When a river's warmer, does it move faster? No, I guess unless it was frozen, but they didn't say, oh, and actually this is a decrease the temperature. I'm sorry, I can't even read. Read the words carefully, people. A decrease in the temperature. If I make it colder, will it move faster? No, even if it froze, it's going to go slower, not faster. Increase in the river's discharge. Vocab word there, what's discharge? It's the amount of water. So if I increase the amount of water, will the river go faster? Picture a water slide. What happens when you put more water in it? Goes faster. So that sounds like the right answer. I do want to double check the last one. What happens if I increase the width of a river? The water spreads out more. And what's going to happen to its speed then if it's spread out? It'll actually get slower. Harley, did you get that one right? Okay. How about the rest? Did you get that one right the first time? Okay, good. All right, question about a delta. It's asking what explains why the river delta is developing at this site. So why do we have it here? So let's go through the answers again. Is it because the rate of deposition is less than the rate of erosion? What's that mean? Deposition is less than erosion. Less are being deposited than eroded away. So would that make this? If less stuff's getting deposited? No, couldn't make this. If less things are getting deposited than eroded away, it means the area is going to get smaller, not bigger. So what about this one? The rate of deposition is greater than the rate of erosion. What's that mean? More sediments being deposited instead of carried away. Would that cause these sediments to pile up? Yeah, that's it. Sea level rising or sea level falling would not be the explanation of why this is forming here. Because in fact, you can see, like, compared to the house, the sea level's in the exact same spot. So that hasn't changed in this picture. Oh, and this one. Oh, before I even go over it, let's again see what you had to say. An environmental scientist needs to prepare a report on the potential effects of a proposed surface mine in New York State will have on the watershed where the mine will be located. In which reference material where the scientists find the most useful data in which to determine the watershed's boundaries. They want to know where the watershed starts and stops. Can I just see what you guys picked? Actually, did anybody know what they were doing? Or did we all guess on, most of us guess on this one? Yeah, okay, then I won't even ask. So let me go to a watershed. Here's a picture of the Mississippi watershed. We looked at a very similar picture when we talked about this. I talked about how big it was. So the boundaries mean where the watershed starts and where the watershed stops. So in other words, do you guys remember what we said is over here that determined what's over on this edge? This is the Rocky Mountains. And so a mountain range makes it so that water that fell here will go this way and water that falls on this side goes that way. Same deal over here. Here's the Appalachian Mountains. So mountain ranges determine or it doesn't even have to be a mountain range, but the landscape, so the hills of an area determine which way the water's gonna flow. Which one of these will show us where a hill will be? So now that you understand what's on each side, which one will show where hills are? Uh-oh, are we not remembering these words? It is one, guys. What's a topographic map? It's the, remember the connected, yeah, it shows the steepness, it shows elevation. They're the maps that connect equal places of elevation. That connect the dots for slightly older kids. All right, we did just talk about what this is. So the answer to number 3 here, this is the Mississippi watershed. Now it says rocks that are deposited at location X by the Mississippi River will most likely have what characteristics? Well, will they be angular and arranged in a mixture? No. Will they be arranged? Will they be sorted? When a river enters the ocean, do they sort the rocks? Absolutely. They will, oh, wrong. I put the circle in the wrong spot, sorry. Number 2. They will be sorted right here. There'll be a pile of big rocks, medium rocks, smallest rocks, tiny particles. They will be sorted. What is this thing called at the end of the river? No, that's not a tributary. That's a delta. What's a tributary? A smaller river that feeds into a larger river. A delta is at the end of a river. Now, question 6 here, the last question you had to do is actually a review question. Most of New York State's sandstone bedrock was formed. Let me give you a hint before you start looking at the answers. What kind of rock is sandstone? Now, how many of you knew that off the top of your head? Couple of you. What happens if you don't know it off the top of your head? This is where your reference table comes in handy. Other than that, you probably had no idea. You're like sandstone. Sandstone. Okay, well, we've talked about that. And then if you look, it's talking about how sandstone forms. So I want you to use your reference table, pretend you're Google. Now, it's super easy to type into Google and say sandstone, and it'll pop right up. It'll be highlighted, whatever. You can't do that on your reference table, so I want you to literally pretend you're Google. Search through page 1, nothing about sandstone. Search through page 2, nothing about sandstone. Now, page 3, it does talk about sandstone a little bit. It shows that some of New York State is made of sandstone, but it doesn't tell you how. But hopefully that jogged your memory that it's a rock. So look through these rocks. Nope. Look through these rocks right there. Sandstone is a sedimentary rock. And the question asks, well, how did it form? Sedimentary rock forms when sediments get deposited, buried, compacted, and cemented together. Which one of these answers says that? Answer number 3. The sandstone bedrock was formed in a delta when sand grains were deposited, buried, and cemented together. Okay, keep in mind these questions would have been worth about 9 points each. Figure out what you would have got, about. Okay, count on them being 10 points each. How many did you get wrong? 1 wrong would have been around a 90, 2 would have been around an 80, 3 would have been around a 70, 4 would have been around a 60. I think you get the point. You have a test on Friday. We made a review sheet and almost all of this stuff would have been on that review sheet to some extent. Okay. We're going to review again tomorrow with a bunch of review questions. We'll go over them on Thursday and your test will be on Friday, but it sounds like some of you need to do some preparing on your own. One thing I would do is re-go over every question we've done for homework. Hopefully you've written down the right answer. Cover up the Cover up the answers. See if you'd be able to come up with the same answer a second time. That's one way of studying. Okay. We'll do some more practice tomorrow, though. We have one more new thing to do. We're gonna go in our packet to page 18. And we're gonna be talking about erosion first. Erosion on beaches. So we're talking about wave erosion. So let me show you a picture of a local area, which is in Evans. Lakeshore. This is not it. We don't have, that's definitely not it. We don't have any beaches that look that nice around here. The water's not quite that clear. Sand's not quite that powdery. But here is a picture of Went Beach during the, obviously it's during the winter. It's not a great picture, but there's a couple things I want to point out about this beach. So I read an article about this actually this morning. So what these people have, so these are some houses right on the water, thinking I'd like to live there, though it might get a little scary when it's yucky out. But during the summer, that'd be a great place to live. What they told in the article are, see these walls here? These are called seawalls, by the way. Any idea what, I guess in this case, they might be called lake walls. Any idea why they might be called that? Yeah, they block the lake, or if this was the sea, they block the sea. When they bought this house, these walls were in line with this cliff back here. So see how the cliff has moved, pushed back quite a bit? They used to all be level. So this is where, I bet that even was even more like this. I think you can even see there's a little faint line there. That's where that cliff used to be. And the cliff has been eaten away. Why hasn't their house and their property? What's good? Why did theirs not look like this now? I mean, that should be right up to their doorstep. Why hasn't their yard and the back porch there been eaten away by the waves? Because of the wall. The wall is stronger than the dirt and preventing the waves from carrying away their sediments, their yard, their dirt. One little structure saved their house. How did the waves carry away those sediments? Any ideas? Okay, first off, it's from what's called longshore drift. So at the top of this page, I think we need to put in a definition. And so we're going to put the definition of longshore drift right here. Right at the top. It's called longshore drift. Sometimes it's called longshore current. And it is the movement of sand. This is movement of sand along the shore. In a zigzag pattern. So it's the movement of sand along the shore in a zigzag pattern. So I'm going to go back to that picture. We're going to talk about how the sand could have been moved in a zigzag pattern. Nope, lost my beach. All right. So let's go back to this screen here first. So one thing I want to point out with this picture is, let's take a look at the waves. There's a few tiny waves you can see. Let's look at this wave right here. Can you guys see it at all, or should I'll make it purple. There's one, there's one, there's another one, there's another, there's another. What do you notice about those waves hitting in front of this beach here in Wet Beach? What do you notice about those waves? Okay, they do look small from here. I can't tell if these are, it must be a pretty calm day, you're right. What way are they hitting the beach straight on? No, do you see that they're hitting the beach at a slight angle? And that's how waves, if you can picture any beach you've ever been to, more often than not, the waves can hit at a slight angle. What I would like you to picture is if you could picture a beach ball being right there, right about to be hit by a wave. It is a big beach ball. I wanted to make sure you could see it. What's going to happen when that purple wave hits that beach ball?
It'll push it.
It's going to push it. Now, it's going to push it the same way the wave is going. So this beach ball is going to be pushed at a slight angle up the beach. Now, what happens when waves like return back to the water? What's going to happen to the beach ball?
It'll go back.
It's going to go with it. Yep. So it's going to come back down. Now it's ready to be hit by another wave. What's going to happen when it gets hit by the next wave?
It's gonna go at an angle again.
It's going to go at that same angle again. And then back. And then back. And then forth. Here's that zigzag pattern I was talking about. So the reason it's a zigzag pattern is because the waves are coming in at an angle. Have you ever been to a beach and put your stuff down and gone and hang out in the water for a little bit and then look back and you're like, my stuff's way over there? You ever drifted away from your stuff out in the water? That's because of this. It's not only happening to this beach ball, it's happening to you. Every time a wave hits you, you get pushed up towards the beach a little bit and then dragged back out and up and back in this zigzag pattern. That's called longshore drift. Again, it's because this beach ball, just like the sand underneath it, I guess I didn't point that out, the beach ball and the sand are moving along the shore. That's where longshore drift comes from. So what's happening is the sand here, every time, now these would have to be some pretty decent waves, so it's not happening on this day, but during any storm, a big wave's gonna come in, hit back here, and pull those sediments out, and then hit again. And during each storm, I bet they lose quite a bit of land during every big windy day on this beach. I'll pull up the article if I have time and see exactly the dates that were here. But it was pretty significant amount of beach loss for them. So again, longshore drift, the movement of sand in a zigzag pattern. Now I have another beach to show this again. Oh, there we go. I'll use this picture here. So here again, same deal. Waves are coming in. You see that they're coming in at an angle. So the waves push it up this way. They get pulled back, zigzag pattern. Places don't like to lose their property. Like I bet those people are really glad they had their wall. Hotels are another thing that like to pop up on beaches. So there's often hotels along a beach. They like their sand. They can charge more money to be a beachfront hotel than to be an across the street or down the road hotel. It can be like a huge difference. To get a hotel across the street could be like $50 to $100 more expensive to get one right on the beach. So they like being on the beach. They don't want their sand to go away. So this first hotel here, Hotel A, they're right at the edge. They're the first hotel on the beach. What's happening to their sand? Okay, it's doing it zigzagging. It's getting pushed over to B. What's happening to B's sand? It's getting pushed to C, but B's okay with that because what's happening at B that's not happening at A? They're getting sand from A. A has no new sand. They're just losing it. So what might A do, because they want to keep their sand, they want to be a beachfront hotel, what might they do to prevent the sand from, they can put up a fence. So one thing they could do, now one thing they could have done, which is what those people did at Wet Beach, they put up a fence at Went. And it wasn't a fence, but it was a wall. They put up a wall right there that held their sand there. Do you think hotels want to do that? Why not? Why doesn't a hotel put up a seawall just like that house did? Right, there's a big wall there. Isn't part of going to the beach to like see the water? You don't want to have to go around the wall to get to the beach. Or to the water, I mean. So they don't put up a wall there. Where they put up a wall is in between the two hotels. What this wall does is prevents the sand from going to B. It stops it so it's still in front of A. Now it might start to pile up here, but A can deal with that. They can hire some people to spread it back out. So they build these walls called groins. They also could be up here. I'm sure you guys have seen these. I'll show you a picture of them. But what's now happening at B? They're not getting any new sand, but they're still losing their sand. So what do you think they do? They put up a wall too. So does C for that matter. They're all going to put up these little barriers called groins to prevent their sand from leaving. So that, by the way, is one thing that you have to kind of see. And so here is that exact picture. So these are structures that are put in place. Now this time the waves are coming from the top of the screen down. So you can see that they're getting eroded away and then piled up on the other side. Again, I'm sure they'll bring in some equipment and spread that out eventually. So this prevents beach erosion. So these are called groins. Seawalls work too. These just might be a little bit more beneficial for a hotel area. Yeah.
If you look really closely from the top to bottom, you can kind of see where it's like faded with the sand into the wall.
Here,
Yeah, where it's like greater.
where it's piling up here.
Yeah.
Yeah, that's exact. So you can see it's being moved from here and piled up over here. And it's at each one of them. Moved, piled up, moved, piled up. Is that what you meant?
Yeah.
Yep. And so now they can bring in a bulldozer and spread that back out if they want. But before this would have happened, all of this area would have had no sand and it would have been piled up huge over here. And this hotel would be like living the big life. And these guys would be like sending their people over to the other hotel. They'd be losing money. Hotels are not friends with their neighbors usually. They're their competition. So this, again, these are called groins to prevent beach erosion. Here's some other things that can happen because of wave erosion. So this time there is no sandy beach. This time the wave is just crashing every day, day in and day out on these rocks. Some rocks are stronger than others. Remember the word more resistant. So some rocks are stronger, some are weaker, and they get eroded more. This is like exactly what it looks like out on the West Coast in Oregon. Here's another example of that. So this, I'm assuming, again, I don't know exactly where this is, but I'm assuming this used to come out much farther into the water and has each day probably eroded a little bit and a little bit away towards the hotels. Xavier, they need you in guidance right now. Here's another example. If you've ever watched Survivor or even, is it Moana? You know, that big rock she's standing on at one point that turns into a human. Kind of looks something like these. Again, it's a piece of land that was more resistant to weathering than the other rocks that were around it, and it stayed up longer. These sea arches, sometimes this gets too heavy and this area will fall in, and then you're left with a shape more like this. Here's a real life one that is actually no longer. This has since collapsed and this area is gone completely now. So going back to this picture, where's the sand going? If this is the end of the beach, where do you think the sand that was at Hotel C was going? Oh, this not a sand dune. This is actually gonna be called a sand spit. It's going to start to gather over here in the water. I actually have an animation to show it. So that last hotel was losing its sand, but it was piling up at the end, making basically a new beach. It'll end up looking, here's a good, so same thing. This was all being pushed and piled up and made a new sand spit. Now a sand bar, ever experienced a sand bar, guys? How many of you have been to the ocean? That's your phone. He's on his way. I don't have that person. I don't yet. Yep. Bye. A sand bar. Ever go into the water? What do you expect to happen to the depth of the water as you walk in?
Slowly.
Gradually get deeper, right? Which is exactly what happens. But have you ever gone into the water, it gets deeper, 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 deeper. My knee hurts. I can't do this too well. And then all of a sudden you're going back up. Ever gone out and it's only like knee deep, way out far? That's you standing on a sandbar. A sandbar, the sand gets carried out from the beach and dropped off a little bit farther out into the water and it piles up there. That's a sandbar. A barrier island is a giant version of that. Kind of like this one. So this would have been the mainland beach. You would have got deeper, 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 deeper. And then all of a sudden it got really shallow and it piled up there so much it became a big, huge island. This isn't even that big. Myrtle Beach, Virginia Beach, Ocean City, Outer Banks, Clearwater. Those places are all barrier islands. They are really exactly what they sound like. They are islands that act like a barrier. So if these waves were a big storm was flowing and hit this island, it will hit here and destroy a lot of property, but it will have slowed down and not hit over here as strong. So they act like barriers during storms. This is what those jetties and groins and jetties would look like in real life if you got closer to them. So this one's just a pile of rocks put out into the water. This one they did actually go ahead and make a wall, but all the same stuff. Here's another example. So this one, they put little tiny seawalls out here to prevent, just to slow down the waves. Okay, guys, I know that one was kind of dull. What do you need to know about wave erosion? You absolutely need to know longshore drift. That's it for today. No homework. You'll have some review problems tomorrow.